Okay, so here we are in section 1.4, which are equations involving radicals. So radical equations are equations with roots. So there is your symbol for your radical. Okay, with the root by itself without a number in here, then we assume it's a square root. Uh, the square root, or the root in general, is the opposite of a power. So, like adding is the opposite of subtracting, multiplying and dividing are opposites, powers and roots are opposite. So, the opposite of a square root is squaring, the opposite of a third root is cubing, etc. Okay, so one thing we always want to make sure as we solve these equations is not only to check your answers, because there are restrictions for uh, even rooted equations, but to also make sure that you're doing the correct power when you're solving, because anytime we solve equations, we're doing the opposite. So let's look at, how we solve them. So given an equation like this, the square root of x is 4. Well, think about it. The square root of 16 is 4. The way we get that is to just square both sides. So I would square the square root and then square the 4. Squaring the square root just kind of like undoes it. So it gets rid of the square root, which allows us to get x by itself. So that's the most basic. It's just a basic square and simplify. Now, next here we do the same type of thing because we do have the square root, and x plus 2 is all contained in the square root symbol. So again, all I want to do is get rid of that radical first. And I do that by squaring. I simplify that, again, because the square just takes care of the square root. It does nothing to the expression inside the square root. Squaring 7, be careful there. It's not 14. You're taking 7 times 7. And then I do one last step. I subtract 2 from both sides to get 47. Okay. Now, when we talk about checking, with these one-step equations, it's not going to be bad if you don't. It's more so for the ones we get on down the road here, but they're very easy to check. You just substitute in the value you get, and you want to know, is that a true statement? And the square root of 49 is 7. So you do have a competent check there, and you're right. Now, as we move on down the list here, we have a cube root. So let me focus in on that there. All right, everybody see that? So that's not a square root, it's a cube root. So that's different. But in order to solve this, we always want to isolate the radical expression. We always want to get the expression with the root symbol by itself on one side. So what I have to do here is I'm first going to add 2 to both sides because this 2 here is not under the square root. So that leaves me with the cube root of 2x minus 4 equals 2. Now, raise both sides to the third power because that is going to undo my cube root. It's just the way things work. Doing that, again, undoes the cube root, and be careful with 2 to the third power. It is 8, not 6. Then I take that and I add my 4 to both sides. Be helpful if I showed it to you. So 2x equals 12 and x equals 6. Okay, so again, I'll leave the check to you, but you just substitute the 6 always back into the original equation anytime you're checking, because you don't know what operations you've performed that may change things, or you may have inadvertently messed up a sign somewhere along the line. All right, well, this next one here, example 4, it's probably going to be the most difficult in these radical type equations. And it's because we have something we haven't seen yet. We do have an expression with an x on both sides. So I have the radical by itself. So I'm going to proceed then to square both sides. Now I want to throw some caution here. It's in this next step when we square the x minus 7. I see that mistake all the time. When people square these, they want to square the x and square the minus 7. It doesn't work like that. So if I simplify the left, I get the x minus 1. Well, x minus 7 squared, it'd probably be better if you just wrote it out like that. That way you won't mess up. Take the extra step. So now I'm going to use my FOIL method. Take my x times my x times the negative 7, my negative 7 times the x here, and the 7 times 7 to get my 49. And then I have x minus 1 is x squared minus 14x plus the 49. So if you notice, if you had done the cautionary mistake I warned you about of just squaring these, you would have the x squared and the 49, but not the 14x. Okay, so what we're left with here now is a quadratic equation. And anytime we have a quadratic equation, that it means we have an x to the second power, we need to set the equation equal to 0 and solve for x. So what I'm going to do is I'm going to use one of those rules we talked about, or procedures to manipulate equations, and I'm going to interchange sides. Then I'm going to add 1 to both sides here. Subtract this x. And don't forget, that's like subtracting a 1x. And what I'm left with is x squared minus 15x plus 50 equals 0. So, talking about factoring, I know we just talked about it the other day in class. There's another instance where you will have to do some factoring to solve an equation. Now, you could do your quadratic formula. No problem there. I just think if you can really figure out how to do factoring, it is much quicker. So what I'm looking for here is, I've got a product of 50 here if you're doing the AC method, and a sum of negative 15. Since this is positive, both of my signs have to be the same. I know these first two are x's. And I know that negative 10 times negative 5 is 50. And I also know that negative 10 plus negative 5 is negative 15. Solving now, what I get is x is 10 or x is 5. Remember, when you're solving, set it equal to 0 and solve for x. Now, here's where it is very important to check. So I'm going to flip this over because I'm kind of running out of room here. Now I'm going to check. So first I'll check x equals 10. Okay, and I'm not sure. That's why I put the question mark up there in case you're wondering. So the square root of 9 is 3. That's good. That's good. So 10 is okay. Now let me check x equals 5. That's a problem, okay, because the square root of 4 does not equal negative 2. The square root of 4 is positive 2. So therefore, what we call 5, it's called an extraneous solution. And an extraneous solution means that in the process of solving this equation, we just happen to come up with this answer, but it's just not a correct answer. So the only solution is x equals 10. Okay, so that's why, normally when you get two solutions, most of the time one of them's not going to be right. So, or one of them's not going to work anyway. So always make sure you're checking, to make sure you know whether you're right or wrong. And then also to see if it solves the equation as far as an extraneous solution. So now that leaves us with one more. And really it's just kind of more of a format thing here. You've got this 1/2 power. Okay, so let me focus in on that a little bit. And this 1/2 power, it's just another way of representing a square root. So a half power is the same as a square root. So you can simply do this if you want. Change it to the square root and then square both sides. So I get x minus 1 equals 4, add 1 to both sides to get x equals 5. And this would work the same if that were a 1/3 power, it would be a cube root. So that's good. Hopefully this one's a little clearer. I'm doing my best. I'm getting there, but I will eventually.